In question 4, ethyl butanoate react with water. So ethyl butanoate plus water, so it will form butanoic acid plus ethanol. A student investigate the kinetics of this reaction. Like student is observing the rate of the reaction. A 50 cm³ of ethyl butanoate was heated and excess, very large excess of water. Why large excess of water? So that the rate of reaction does not depend on the change in concentration of the water. After 30 minutes, a sample of a known volume was removed and a mixture was placed in a conical flask. Then the sample was titrated using sodium hydroxide. So sodium hydroxide will react with an acid. Further samples were removed. This is actually what we call that as a sampling out to work out the rate of reaction. Further sample was removed from a reflux mixture at 30 minutes interval. Each sample was titrated until the titers 3 consecutive samples are same. Means the reaction has completed, no more changes there. Name the apparatus which is most suitable to remove a sample from a reaction mixture. So how we can, like, if we want to remove, we want a specific amount. So like a single fixed volume rather than using because a measuring cylinder and a burette, they can measure a variable volume. But if you want to measure a single fixed volume, so what are the best apparatus? So you can use volumetric pipette or volumetric, even pipette is the best because it can measure a single fixed volume. So mention a pipette. Why not measuring cylinder or beaker? Because they can measure variable volume. We just want to make sure that we measure a single fixed volume. That's why pipette is the only option answer here. The graph for the results obtained by the students is shown. The student plotted the final minus VT. On the final is a volume of a titer at 4.5 and VT is a volume of titer at time t, like how much he removed compared to in 4.5 hours. Give a reason why V final minus Vt is plotted on the y-axis rather than the concentration of a sodium hydroxide solution for each titer. So why we took a difference? Why not like concentration? Look, V final minus Vt, when the difference will be zero, like the final, like V final minus Vt. V final means like what amount we need at the end of experiment, and Vt means what amount we need at a certain time interval. So if we, for example, in the beginning, the say the final amount or at the end, the final amount we need is say 30 cm³. And in the beginning, we example need 2 cm³. So how much is difference in volume? 28. But then what will this will remain 30, but this will like the volume which we need at a certain time interval that will start to increase. Because like in the beginning, this sodium hydroxide is reacting with acid. So in the beginning of experiment, when we remove the sample, we'll have a small amount of acid. So when we have a small amount of acid, we need a, like this volume will be smaller and the difference will be greater. But as this volume which we need start to increase, what will happen? The difference will get smaller. And eventually what will happen will like eventually what will happen? Eventually the difference will be zero. Like VT and VF is zero, then we will stop the experiment. So why we preferred, like why we take a difference in the volume rather than just taking a concentration of a sodium hydroxide which we need for a reaction. So the main idea is that, as you can see, the difference in the volume is directly proportional, or it is proportional to the presence of, if we have a greater amount of in the mixture, if we have a greater amount of ethyl butanoate, the difference in the volume will be greater. Because if we have a greater amount of ethyl butanoate, we'll have a small quantity of butanoic acid. If small quantity of butanoic acid, small amount of sodium hydroxide is needed for a reaction. But as the reaction progress, the amount of ethyl butanoate will decrease and amount of butanoic acid will increase. So if the amount of butanoic acid will increase, the difference will get smaller. So the main reason for because it can be done with a concentration, but if we use a concentration of a sodium hydroxide, then what will happen? The concentration of a sodium hydroxide is directly proportional to the presence of means the amount of sodium hydroxide or its moles is directly proportional to the product, the concentration of a product. But we want to find the chemical kinetics. So we want to investigate how the concentration of the reactant affect the reaction. So the main reason why sodium hydroxide is not used here, like the concentration or the volume of a sodium hydroxide is directly not used, because the volume of sodium hydroxide is directly proportional to the concentration or amount of acid, not the reactant. But the difference in the volume is directly proportional to amount of the reactant. Is it clear? Because whenever we want to relate or work out the chemical kinetics, we want to find the effect of reactant, like how the reactants are changing or how reactants transform rather than the product. So the main reason is because we are investigating the chemical kinetics. So the main reason, the difference in the volume is actually changes with the reactant. That's why if you write here, the difference in the volume depends on the amount of reactant. That's why we use the difference in the volume rather than the concentration of sodium hydroxide. Explain how the data collected indicate the first order. So for if it's a first order, what you have to do, you have to take a half life, like 50 become 25. So what is the time interval? It will be about 7.5, I guess, or yeah, 7.5. And then, or you can take 20 and 10. So this should also be 75. So half-life should be constant. You have to clearly show on the graph. The student conclude that the reaction is overall first order. Explain whether or not this statement is valid. So student concluded that overall this reactor its reaction is first order. We know, look, the rate of a reaction is equals to K times the reactant constant concentration of the reactants A and B. In the question, what are the two reactants? The first reaction is ethyl butanoate, and the second reactant is water. But in the beginning, what we did, we use excess, like we use a bulk or excess of a water, so the amount or the concentration of the water will not affect the rate. So if the amount of the reaction or amount of the reactant does not alter the rate, like amount of a water does not alter the rate. So what will be this rate is equals to K times the concentration of ethyl ethanoate. If the ethyl butanoate. So if the ethyl butanoate is a first order, this reaction is first order with respect to ethyl butanoate, and overall the water concentration does not affect. So overall reaction is first order. You can mention that with reference to that because the water is in excess, like the change in the concentration of a water. So the water is not affecting the rate. So only the rate is affected by the change in the concentration of the ethyl butadiene. Is it clear? Calculate the rate of a reaction at a time 2 hours, include the unit, and show you're working on the, for 2 hours. What we have to do, we have to plot a graph, like we have to draw a tangent, mark a point where time is equals to 2, then draw a tangent, length of the tangents at least like 5 centimeter. Tangent should touch only that single point and work out the gradient by using a formula y2 minus y1 over x2 minus x1. What about the unit? The y-axis, the unit is centimeter cube, and on x-axis we have r, so it will be centimeter cube per r. Then the student suggested that placing ice in the conical flask before carrying out each titration. A student suggested placing an ice in the conical flask. Explain whether or not this suggestion would improve the validity of the data collected. Look, what actually happened? This reaction, even when we do reflux under condenser, when reflux under condenser, and how for how long it is done for 4.5 hours. So means this reaction is having a very high activation energy. So if the reaction, even when we are boiling and reflux under condenser, when we boil and reflux under condenser, the reaction is slow. So how the ice will reduce the rate of this reaction? So in this case, because if, for example, if the reaction was happening at room temperature and then we use ice, then it make a difference to the rate of reaction. So even at 100 degree, the reaction is very slow. So even if we use the ice bath, it won't make much difference to the rate of the reaction. So you can mention this reaction because it is done in a boiling water. So this reaction is having a high activation energy. And is it is having a high activation energy, so done in a reflux condenser. So if we place in the ice bath, the reaction or the rate of a reaction will not change. So even that will not affect. Like this is like what we say, quenching, like changing the condition and quench or reduce the rate of this reaction. Is it clear, this one?